Hi, now let's talk about the binary digits, what they are. So by the binary digits, we mean the sequence of zeros and ones. Like the numbers usually in the binary is written like this: 1 0 or 0 1 0 0 1, and it could be like 0 0 1 0 1, something like that. And yeah, the CPU only understands the machine language. So if CPU is running a program, that the instruction must be written in the machine language, and the machine language is written with the binary digits. So it's the machine language written with the 1 and zeros only, 1 0 1 0, and different type of ones and zeros. And so this means CPU only understand binary digits. And as you guys see, it's hard to write instruction using 1 zeros, and it's also time consuming. And just one error, like you have 1 1 0, if you just make one mistake and you write it 1 1 1, then this is gonna cause the whole program to not able to run because of this error. So that's why a low-level language was created. Low-level language. Created, it's called assembler language. And the way it works, instead of writing instruction using ones and zeros, you write the instructions using short words. And but we said the CPU doesn't understand any instruction except the instruction written in the binary digit. So how the CPU is gonna understand the instruction written in the assembler language? This is where the assembler comes in. It's used to convert assembler language, instruction written in assembler language, into binary digits. So it's kind of like you would into binary. Oh, it's not obvious over there, so let me type it over here. Into binaries. It's kind of like a translator. Like you give him the instruction written in the assembler language, and the assembler converts it to the binary. So that's how the CPU gonna understand the instruction written in the assembler language. So by creating assembler language, it was easier to write the codes, and the error was less than using the binaries. And the reason why it's called assembler language, the reason why it's called the low-level language, because it's so similar in its nature to the machine language. That's why it's called the low-level language. But as we said, the assembler language was so similar in the nature to the machine language. That's why it was hard to write instructions using the assembler language. Even though it was easier than the machine language, but it was hard, and it required a lot of understanding of how the CPU works. That's why the many different of high level languages was created. And high level languages, we mean by that C++, Java, So yeah, the reason why the high level languages was created, as we said, reason was because first it allowed programmer to concentrate on the programming rather than concentrating on how the CPU works, because the low-level languages were so similar to the machine language, so it required a lot of knowledge about the CPU. But with the high-level languages, you don't require to have a lot of knowledge about the CPU. You just concentrate on programming, you concentrate on the task itself rather than the CPU. And also they required less instructions. Like, let's suppose if you need to write a program using assembly language, you would need 100 instructions, but with the high level language you could need maybe like 10 or maybe like 20 or something like that, around that. So that's why it's that's the two main reasons why the high. And as assembler used to transfer or translate the assembly language into the machine language, we have compiler and interpreter to transfer, used to convert high-level languages into machine language, which is language that used by the CPU. So what's the difference between the compiler and interpreter? Compiler allows to translate our high-level languages to the machine language, and then save the code that has been translated. So you could, sorry about that. So as we said, compiler allows to translate the code into machine language, and then you save the code, and you can execute it later without the need to the compiler. So the way it works, you use compiler, you translate, and then you don't need that compiler anymore, because it's already has been translated to the machine language. So no need for the compiler. And on the other hand, we have the interpreter. The way interpreter works, it's translates and executes at the same time. So you translate it and then execute it at the same time. You can save it and in order to execute it later, because it's not like the compiler. So that's the difference between the compiler and interpreter. With the compiler, you can save the code and to execute it later, but with the interpreter, you can't do that.